Hello. The purpose of this recording is to share some unstructured knowledge about how the web works. So, if you can't notice, I'm currently moving. Can't promise the audio experience will be perfect. So, listen at your own risk. And RIP headphone users, you may hear some random loud sounds. My recommendation is that you use this to kind of complement the work that you're doing for the class and videos that you're watching. So this isn't something you should need to sit down at your desk and listen to with complete focus. What you could do is do something else. Take one of those times when you would normally put on music or a podcast and just listen to this to kind of help put these concepts into your brain. It may be the most annoying thing to listen to ever, but my hope is that it'll help some of you out. So first, I'm just going to start from the very basics of the web. How does the web work? So you're probably familiar with the internet, networking to some degree, computers, and the web. The web, as in like a spider web, is basically just a bunch of computers connected together by a combination of physical wires and radio communication. And in the modern day, those have been put together in very clever ways to be able to share information in lots of different methods. So at the core, computers talking to each other is just zeros and ones, and that's digital communication. Or it could be variable numbers that exist on a spectrum that could go, you'd have 0.00000099 or something, and that would be analog communication. But computers mainly use digital communication, and everything that you're sending and receiving through the web or the internet is ultimately coming down to zeros and ones. And if it goes over some sort of electrical or radio communication, it might get converted back and forth between analog and then back to digital on the other side. So the web can communicate things like plain text, communicate special data formats like JSON, JavaScript object notation, or some sort of markup language like HTML, hypertext markup language, or XML, which I think stands for extensible markup language. And it could even be things like pictures. You could have a picture like a JPEG, a JPEG, or a JPG file, or a PNG file, which are just pixel maps. So they say, here are all the pixels in this image, where they should go, what color they should be, and that's the image. Or you could have vector graphics, like an SVG, scalable vector graphic, which is, for example, something you could create in Figma or PowerPoint, and then you could export it as an image that is scalable, meaning you could zoom in on that image as much as you want. It'll never get pixelated because it's essentially a blueprint for how to create the image and not a map of the pixels themselves. So any of those things can be transmitted over the internet, and that's how a lot of websites and web applications work. It's just different types of data. It's ultimately zeros and ones being sent around the world to different computers and passed around, and through various layers of networking. It's not so simple as, you call Google's server. You're not necessarily talking just to Google. You talk to a lot of intermediary network points, and basically you're calling Google and your message is getting passed along through a lot of different places, and then it finally gets to Google, and then they send a response back to you. That's the basic idea. A lot of it you don't have to worry about because there are levels of what's called abstraction. Think like abstract painting. When you were in preschool, it's just a bunch of splotches of color. So basically, you don't have to know all the details of what's going on under the hood all the time. You just sort of abstract that away, meaning you just kind of make it these big blurry splotches, and then you worry about the higher level concept that you're worried about. So hopefully at this point you should be a little bit familiar with HTML and CSS. And now you're either getting into JavaScript for the first time, or you've done JavaScript and you're getting into more advanced web scripting languages and web scripting techniques. So HTML, as a refresher, is a document markup language. Think about document like a Word document or a Google Doc or any other collection of essentially just text where you have different headings and different paragraph types, and you can have bulleted lists and numbered lists and stuff like that. But the advantage to HTML is that it's built for interactivity, which means you also have interactive elements in HTML. Like, you wouldn't just have maybe a paragraph of text, but you could also have a text input where you could type into a box and then that text could go somewhere. So you move from being able to have documents like a Word document that are what they are, to a document that you can then edit and manipulate and do different things like move a slider or select from a drop down or click a button. So at the high level, that's what HTML is. CSS, that's the styling component. It stands for cascading style sheets, and essentially means how we're going to make things look different or behave differently in the browser. So CSS can handle things like colors, font sizes, animations, transitions, and it can even query, or query just means ask, or question. It can ask the browser about users' preferences for certain things or users' current situation. Like, for example, CSS can ask how wide is the current user's viewport, meaning essentially like the window that they're looking through, not the whole browser window, but just the part where the website is displayed. It's like a little window into your application. So you can shrink that window, grow that window, and that lets you look visually inside your application. So you can say, how wide is the viewport, or how tall is it? Or it could ask, what color mode does the user prefer? Do they like dark mode, or do they like light mode? And that way it can show them different styles based on their preferences, for example. So what's often confusing about CSS is people always tell you that the styling comes from CSS. But that must be a lie, right? Because you can make an HTML file with no CSS and it looks like something, right? The reason for that is that there's default styles that HTML can have. So if you make a button by default, each browser might vary this a little bit, but by and large it's going to look quite similar across devices, what that basic browser button looks like, or that basic browser heading looks like. By default, that heading is going to be, the heading 1 is going to be a larger font size than heading 2. Now that's completely overwritable with CSS, but there are default styles. So it kind of saves you, if you want to not think about how things look for a little bit to worry about functionality, you can just use the default HTML styles, and then you can just not write any CSS at first and worry about just the HTML to get your document structured, and then JavaScript to worry about interactivity. So the most basic kind of JavaScript that you can use, you'll often hear referred to as vanilla JavaScript. The reason that it's called that is they're thinking of it as like a flavor of JavaScript, like an ice cream flavor. Like you might have strawberry or chocolate or pistachio, but this is just vanilla because it's completely plain. It's the most basic form of whatever you're doing. If you think about, anything that you might do, let's say you do some sort of, martial art like karate. So if you did a vanilla version of karate, it would be the basic version that everyone learns across the country or across the world. And then if you did sort of a certain flavor, a different flavor of karate, that would be like maybe some moves or some techniques are some things that they teach in one school but not in another. So JavaScript is kind of like that, where vanilla is the basic stuff. It's very, very standardized. It's common across all browsers which run JavaScript. It's common across all JavaScript interpreters, such as the one in Node.js, the one in Bun, the one in Dino. And these standard features are very well documented, and they do change over time. The standard evolves, and so there will be different versions. But in general, there are features that are core to JavaScript that you can use regardless of what flavor of JavaScript you're using. So you might start using React.js, and you might have functional components that create your application. That is not a part of vanilla JavaScript, but vanilla JavaScript still applies. For example, something you can do in vanilla JavaScript is declare a variable. Const means constant. Const space the name of the variable, so say ABC, and then equals, and then you could make it equal to a number like 15. So then the variable ABC is equal to 15. Now you could do that in vanilla JavaScript, you can do that in React.js, you can do that in Angular, you can do that in Vue, you could do that in, any kind of JavaScript world that you want to jump into. But vanilla is going to be the most basic and universal of those. And so while vanilla often takes a little bit longer to do basic things, it's a little bit more complicated, it doesn't handle a lot of common issues and challenges that people face in web development, it is possible to build pretty much anything in vanilla JavaScript, because even all those frameworks like React.js, those are ultimately just built in JavaScript and WebAssembly, because those are the only things that will run in the browser. So that kind of gets to why JavaScript. Why can't I just run Python? I know Python. Why can't I just do Python? Well, for some history reasons that I'm not going to go into, and just to alert you, I may sometimes tell you, here's a signpost. So when I say signpost, think of like a signpost on the road. I'm saying, hey, look at this signpost. I'm going to tell you a word or a phrase, and you can go Google that phrase and learn more about it. Watch YouTube videos on it, whatever you want, but I could go into hours of discussion about it, but I don't want to do that on every little topic. So, where was I saying that why JavaScript and WebAssembly? Well, go ahead and Google signpost, the history of JavaScript, or the creators of JavaScript. It's a pretty interesting story, but some of these things just happen out of history, and so JavaScript became the de facto, meaning by the fact, the standard kind of scripting language or programming language for the web browser. And it was kind of a patchwork in the past of different implementations and incompatibility issues between, say, Safari or the Netscape browser or the Google Chrome browser or Firefox, but a lot of that has started to come in line in recent years. And so for these historical reasons, JavaScript became the only programming language that runs natively in the browser. Natively means it's ready to run JavaScript right away. You can right-click any web page, inspect element, go to the console tab, and you can start typing JavaScript right there. The browser is ready. It has built-in JavaScript interpreter ready to go. So, wait for this truck to pass. So essentially, you need to know JavaScript, or you need to be able to write code in a way that you can not use JavaScript if you don't want to. So what do I mean by that? Well, in recent years, there's also been a new technology called WebAssembly, WASM, W-A-S-M. If you want signpost, search WASM, W-A-S-M. Basically, WASM stands for WebAssembly, and it was an idea to standardize the way that JavaScript interacts with the browser and the way that JavaScript interacts with other JavaScript interpreters and runtimes. Runtime, think about just kind of another piece of code that runs your piece of code, something like that. And they want to standardize this so that you could actually target an underlying language from other high-level languages. Like, for example, you might want to use the Rust language or the Go language or the C language. And so WASM was the standard underlying quote-unquote assembly language. It's a little bit more verbose, meaning wordy, and a little bit harder to write, but it would be very powerful and universal. And this is comparing directly to ASM or ASM, signpost ASM, assembly language. Now, there are lots of different flavors of assembly language. What it comes down to is, in the history of computers in general, pretty much the most powerful and foundational programming language, and yes, it is technically a high-level programming language, is the C language. And in C, you would write code, and then there was a compiler, which would take your code and turn it into assembly language, and then assembly language would be interpreted by your operating system to interact with your computer, by converting it into machine language, which is literally zeros and ones. So your high-level language becomes this hard-to-write, wordy assembly language. Assembly language then gets turned into zeros and ones, machine language, machine code, signpost machine code, and then machine code is literally run through your CPU like an assembly line. You know, it only knows how to handle sequences of zeros and ones. It does very specific things when that happens, so those zeros and ones have to be perfect when they go through there. So that's why there's all this translation. And so WASM is kind of like an analogous, meaning it's like an analogy. It's similar to the assembly language that is targeted by C, or if you were to compile another compiled language like Rust, you can compile that also down to assembly and machine code. So the idea was, what if we could do that but for the web? So we could write web code with other programming languages. And that now is possible. You can, for example, write some C++ code, and you can compile it and target, meaning the goal of the compiling step is to take your code and translate it into WASM. And then WASM is something that your browser can run. But it's not quite as simple as just like, I can just start typing some, Rust or some C++ in a web browser, in the console window. It's not that simple. You essentially have to ship, or by ship I mean send a file. Remember, you can send images, you can send text, you can send anything. So you can send code. So you can send a WASM file over the web to the user, and then the browser now has APIs, or application programming interfaces, where with just a little bit of JavaScript, you can hook in to that WASM, and you can do the bulk of the computing that you want to do inside that WASM, and then get the result back out using JavaScript and hook it into your HTML to show it to your users, for example. That sounds roundabout. It kind of is, but it just demonstrates how foundational JavaScript is to the web browser. Almost no interactive experiences that you'll have through a web browser will happen without JavaScript. It's possible, but mostly nowadays, that's how it happens. The alternative would be, for example, when you submit an HTML form, signpost HTML form, you could have an action that would make an HTTP, hypertext transfer protocol, request to a server, and it could, for example, run a PHP script. PHP is a server-side scripting language. So it would run that script and transfer the contents of your form over the hypertext transfer protocol, and then that PHP code could maybe put your data in a database, for example. And so it's possible to do some of that stuff without using JavaScript by just using the very bare bones kind of HTTP, which is, if you think about the browser bar when you type HTTP or HTTPS:// and then your website name, that is the protocol it's sending over, and that's the protocol that HTML files are going to get sent over. It's the protocol that CSS files and images that are embedded in your HTML are going to also be transferred over. So that's a way to sort of avoid using JavaScript. And there are newer technologies like HTMX, signpost HTMX, that also get into kind of taking that concept to the max and seeing how can we do things on the server and kind of plug in content by using just HTTP and talking back to our front end, meaning what the user sees. So now might be a good time to get into what does that mean, front end versus back end. Well, you've been kind of hearing me mention you have the browser. I keep talking about the browser. The browser is pretty much always the client, the front end in a web application. Now, not necessarily. For example, I could write some Python code that talks to google.com. So in that case, my Python code would be the client. I'm making an HTTP request, which is, again, a protocol on top of the network protocols below it. There's those levels of abstraction, and HTTP is the transfer protocol that I'm going to use. One sec. That's the transfer protocol that I'm going to use to get an asset. And by asset, I mean just a file, a piece of zeros and ones. It could be anything. It could be text, image, WASM, HTML, anything. I want an asset from Google. So I'm going to request the Google logo because I know the location of that. So Google hosts, meaning they possess an asset and they host it. They keep it available 24/7 and they expose it. Expose, think about, oh, I'm really vulnerable, I'm exposed. You know, I lost all my clothes, I'm exposed. So Google has a computer, a web server, or more accurately, a lot of computers in a very complex architecture that exposes their assets to the world. So you can call google.com. You essentially talk to a DNS, domain name service, a DNS provider that says, let me see who google.com is. And then they get an IP address. Maybe that's, 8.8.8.152. Or maybe it's that would be an IP version 4 address. Maybe it's an IP version 6 address, which was created because essentially we were running out of IPv4 addresses. So people need to come up with an address system that could have more addresses. So IP version 6 addresses are more like, 3F2C:A417, something like that. And they keep going, and they're quite long. And they have letters and numbers and colons. And so that address is kind of like Google's phone number. So we call up Google, and then they route our request, signpost request. We made a request to Google because we wanted to get an asset, their Google logo. And Google might use a really complex architecture. They might have a load balancer that assesses all their servers that serve this asset. They have the asset maybe in 10 places in case five of their servers go down. They still have 5 places they can get it from. So they never have any downtime. And they use a load balancer. And it balances the load. So when 1,000 people ask for the Google logo at once, they can spread that out between their 10 servers. Or maybe they're 9 because one is down. So your request gets routed, signpost route. Route can mean a lot of different things, but in this case we mean network routing. So your request gets routed through this is kind of the last mile, so to speak. The UPS driver going from the last office to your house. The last mile of your request is that load balancer is going to route that request somehow to an actual computer. And here's the secret about the cloud. It's going to blow your mind. There's a really good meme, and it says, the cloud is a myth. It's just somebody else's computer. And so that's the secret. There's no cloud, guys. It's just a bunch of other computers set up in really clever ways. So the request is going to get to one of those computers finally, and that computer is going to find that asset, physically a file saved on your computer. Just like you download, you download the Google logo, let's say, and it's on your desktop, on your PC, on your Windows computer. Google has that file somewhere on a hard drive, maybe replicated across 10 hard drives on the same machine, across 30 machines, across 500 regions, across the world. They might have, 10,000 copies of the Google logo at any given time. But you're going to get one of those. And then finally, Google is going to send a response, signpost response, where over the Hypertext Transfer Protocol, HTTP, or HTTPS, which means that it's added encryption, it's going to send that asset back to you, all the way back through all those different waypoints, all those different routing steps, back to your computer, and you're going to be able to view that because your client, your browser, is able to display images. Pretty complicated, right? So, where do we go from here? Well, if you're learning JavaScript for the first time, what you're going to learn to do is interact with HTML documents. And a lot of that will center around the document global variable. So any JavaScript file you open, you're going to link it into your HTML using a script tag. Your HTML will have a script tag, and then in that script tag, you can either just write JavaScript right in the script tag, or you can specify an SRC, source attribute, on your script tag and list the path where that asset, remember, code is an asset too. JavaScript files are files, they're assets. And where that asset can be found, wherever the website is being served from, signpost serve in the context of serving websites or serving web pages, web server. And so you can either write that code right there in the script tag, or you can use the SRC attribute to specify where to get that asset of that JavaScript file. And then when that is put in there, it's going to automatically run that JavaScript file top to bottom because it's a script. That's what scripts are. It's like a script for a play. The actors and actresses, they're just going to look at the script, going to read it from top to bottom. That's what scripts do. They read from top to bottom, they execute the code using the JavaScript interpreter, which in the browser is built in. So that's great. So, what you might do, in that script, there's going to be a global scope. Global meaning it's everywhere, it's the whole world. And you're going to be able to access a variable called document. Now, you didn't create a variable called document, but it's just there. That's how it works by default. So what's going to happen is the script will run from top to bottom. But let's say you put your script tag above your HTML body. And if you don't recall, the HTML body is where everything that you see on the HTML page is going to be located. There's going to be some other metadata that kind of tells the page what it's about, brings in, CSS files, stuff like that. But then what that user actually sees is contained inside a body tag. So let's say your script is above the body tag. Now that HTML is also going to get read top to bottom, sort of like a script, just top to bottom. So if your script comes first, your script might do stuff before the stuff is on the page yet, before the browser has done what's called painting, signpost browser painting. It hasn't literally painted up those letters and those input boxes and those buttons onto the screen yet. So what you're going to have to do is use a window method called onLoad. So window is another global variable that's automatically defined for you because you're in a browser that you're going to be able to access globally in your JavaScript. So that means all the way tab to the left, no special anything, you can type window or document in your JavaScript file, and that's going to be a variable with stuff on it. So type window.onLoad. Window onLoad is going to take a function, and it's going to run that function once the window has loaded. So that would save you from the hazard that your script runs before your browser has painted your HTML out because it was above it in the HTML. So it happened first. So sure, you could easily just put that script tag below the body and then it's already there by the time you go to do your JavaScript. But why is this a problem? Well, let's say we want to use document. Document has these methods where you can programmatically access pieces of your HTML document using functions. So for example, you can say document.getElement by ID, and that will allow you to find any HTML element or HTML tag that's in your document. For example, let's say you have a button and you have an attribute on that button. So inside the button tag, you have the attribute called ID equals, and then in quotes you have, BTN. So BTN is the ID for that button. And then in your JavaScript, you say document.getElement by ID, and you pass in the parameter BTN in quotes. And so that function is going to return the button that is in your HTML document programmatically. So that, for example, you could programmatically change the text inside the button. So maybe you want the button to say click me. So you say, document.getElement by ID, BTN, and then something like, I forget exactly, but maybe inner text or inner HTML, and you'll set that equal to click me in quotes. And that could programmatically change the button. But what's this problem I was talking about before? So if your script tag was above the body of the document and the button is in the body of the document, then the button hasn't been painted by the time the script runs. So document.getElement by ID is going to return null, nothing. There's no button. It doesn't exist yet. So you either have to move that script tag after the body, or you could use window, which is just another API, whereas the document represents the HTML document, the current HTML document. The window represents the browser API. Lots of methods in there, like window.bluetooth. You can actually access Bluetooth on your device through the browser. That's how powerful the browser is. And so the window is going to give you lots of different things that you can do, cool functions, so you don't have to write those yourself. You just use the browser's built-in methodology for doing that. So it's pretty cool. And one of those is window.unload, which basically says once the window has loaded the page, like think about reload, when you click the reload button to refresh the page. Window.unload, when you load the page for the first time, then all that stuff, the browser is going to paint the HTML and it's going to run the JavaScript. So when it's on load, meaning when that load event happens, signpost, web, browser, events, JavaScript events, when that load event happens, you are writing something in your script that says, hey, when this load event happens, run this function. So it's confusing because your script runs top to bottom, right? And that happens as soon as you hit that script tag in the HTML, it's going to load. But you might be like, well, you said this doesn't happen until the load event. And that's true. Your script is going to run top to bottom, and it's going to set that load event. It's going to say, when this load event occurs, what do I want to happen? So that plan is executed right away. But that actual action of what is going to happen as part of that plan, that action won't actually take place until the event happens. So this is a very fundamental concept in JavaScript, asynchronous programming, assign post, asynchronous programming, promises, futures. These are very fundamental concepts that your code is going to execute top to bottom because it's a script. But it might register or plan or hook in and say, here's some things that I want to do asynchronously. Synchronously meaning right now, asynchronously meaning the A means not. So not synchronously, not right now, but more so just kind of at the time I specify. So in this case, window.unload is saying add an event listener to the window object, and when an event occurs on the window object that says load, then run this function. Okay, surely I have explained that well enough at this point. So window.onload runs, and then even if your script tag was above your body and the button hasn't been painted yet, that event won't fire and your function won't run until the load has happened. And by that time, the browser has in fact painted your button. And so now if you, inside of your function that you pass to window.onload, inside of that function, if you call document.getElementById btn, that element now will not be null. It will be non-null. It will be defined rather than undefined. It will be a programmatic representation of the button element that is in your HTML document with which you can interact and, for example, change the inner text to be click me. Now, that might not be something you would want to do because more likely you would type click me just right in the HTML document if that's what you wanted to say. But, maybe you wanted to say click me, and maybe you want to add an exclamation point when the user hovers over. So that would be something you could do programmatically so that it looks one way by default, but then when events start to happen in the browser, events just like the load event, events like the the hover event over an element, then you could trigger some kind of thing to happen programmatically. And that's kind of the core of what's happening with basic JavaScript. So when you start moving into non-vanilla JavaScript with frameworks like React, what's happening is they're just putting together vanilla JavaScript in really clever ways to be able to provide more convenient functionality for doing common tasks. So for example, they help you to do things like state management, signpost state management. And they help you to manage the document object the DOM, the document object model. They help you to manage that more easily using a bunch of different kind of convenience functions, and they have you think sometimes in a different way. They think about programming in a different way, whereas vanilla JavaScript, you just kind of select things in the HTML, you add event listeners, and you create functions that do things, and you hook them in, and call it a day. With these frameworks, you kind of build things up and do a little bit more complexity with your JavaScript. So final thing I want to touch on is the difference between regular JavaScript, regular vanilla JavaScript, bundled vanilla JavaScript. So when you have a website, you have these files, these assets, right? An HTML file, a CSS file, a JavaScript file, or maybe, let's keep it simple, you just have an HTML file and it has inline CSS. So it has a style tag and it has some CSS defined in there to style the page, and it has a script tag with some inline JavaScript that does some interactivity. So that maybe it says, it does a window alert when you click a button that says hi mom. And so that is something, one file, HTML file, static asset that can be served by any web server. Okay, so this is super simple. This is the simplest way to do it. You have an HTML file, has everything in there, one file. It's called index.html. Then you put that file into the root directory, root meaning the highest level, the base level, where all of their subfolders live. And this is kind of like a directory structure on your computer. Same way you have files and folders on a computer, web servers are computers, and they have files and folders, and they serve files, assets, using the hypertext transfer protocol, and they map that same structure as is in a directory. So let's say the server has the name or the origin, signpost web origin. It has the origin of my subdomain of my personal domain that I serve a lot of my web assets on. And so that subdomain is n.gardella.cc. So the top level domain, TLD, signpost top level domain, is CC. Under CC, or maybe Gardella is the top level. I think CC is, like com, net, edu. I think CC is the top level. And then my domain name is Gardella. And because I own, or I rent, and I manage that Gardella.cc, pro tip, I think I got that domain through Cloudflare. And let's see, I think I got it for 10 years for something like $10 a year, something like that. So not too bad. But I manage that domain, and so I could create a subdomain called N. So N is a subdomain of Gardella, and so I have this site n.gardella.cc, and I set up my GitHub pages. GitHub pages is a way that you can deploy public static websites. The important term there being static, signpost static website versus dynamic website. And GitHub pages will let me serve static websites through GitHub repositories. So I just configure everything correctly, and then I can direct, when somebody goes to n.gardella.cc, it can go to GitHub pages and get my website. So literally get those requests, get those assets, just like we got the Google logo earlier. And so let's say that really simple structure where you just have an index.html. If I've registered that origin, and the way GitHub Pages works a little bit, it splits your origin into multiple subsections so that you can have different repositories go to different places. So by default, maybe your GitHub username is, let's say, reg. So you got the GitHub username reg. So your GitHub profile is at github.com/reg, and your GitHub pages that's reserved for you by default is actually going to be a subdomain of GitHub. So GitHub is going to give you something like reg.github.io. So that is your personal little subdomain that they allow you to use, even though it's theirs. And you might have a repository called ABC. So you're going to have reg.github.io/ABC. And in that ABC repository, you set up a pages site to serve a single index.html file, and that has your HTML, your CSS, and some JavaScript inside of a script tag. And you configure that. So what's literally going to happen is when you go into a browser and you type in that web address, reg.github.io/ABC, it's going to call GitHub. It's going to call github.io. It's going to say, let's talk to the subdomain of reg, and then in reg, it's going to say, give me the subfolder of ABC. And so GitHub is clever, and it organizes your code so that you can have those multiple subfolders. And so in this case, you think of your website as being, a single origin like reg.github.io, but more than likely what you're going to have is really a subfolder on a single origin. I know it's confusing, but just bear with me. You have multiple repositories, ABC and BCD. ABC is going to be under the ABC folder, and BCD is going to be under the BCD folder. And so you can deal with that stuff when you want your website to kind of act like it has its own server, even though it's really one server that manages a lot of different subfolders. But essentially, your browser is going to talk to GitHub, ask for that index.html file, and you're like, well, you never typed in index.html. Why did it get that? That is the default thing that your browser looks for. Index just means it's like, an index in a book. You go to the back of the book, and you can look up different words and terms and find where they appear in the book. What page are they on? So index just says, when I go to reg.github.io/ABC, index says, hey, here's what's at that place. Here's what you can find there. And so it automatically renders that index.html file in the browser for the user. And then all that stuff happens. The HTML gets painted using the CSS for styling, and the JavaScript script tag gets run. And so that is the simplest way to deploy a website. You give somebody who's willing to serve your website, and in fact, GitHub will do this for free. You give somebody your static assets, and they ship them out for you whenever people ask for them. And then the website just works, and you don't have to maintain any kind of server to serve dynamic content. Now, in reality, a lot of useful websites will be dynamic, and that's because they need to serve something more complicated than just static assets. And you can do a lot with static assets, because remember, you have JavaScript, you have WASM, you have all kinds of functionality from the browser and the document, and you can do amazing things. But all that data and all those activities are going to happen on the client side, meaning on the user's browser, or whatever is asking for that asset. Say it's a Python file, or it's a Go program that requests this website, whatever it is. But more than likely, the whole purpose of this is you're going to have the client be a browser. So you can do a ton of stuff on there, but what you're not going to be able to do is, for example, have that data saved in the cloud, i.e. on someone else's computer, unless you set that up. So you can create a static asset that uses JavaScript to go and talk to other servers to save data. So for example, you could ship out a static HTML file with a script tag that uses HTTP requests like get and post and put, signpost HTTP requests, and it could talk to some external server using some kind of authentication, like the user enters some password and email or credentials, and then that gets sent to the server to tell the server who they are, and then they can put some data in that server. But then guess what? You're going to have to either maintain that server or figure out some way to reserve space on that server. And so you can see how it gets pretty challenging when you have when you start to have external data saving, where the users aren't keeping all the data on their own device. You start to be responsible for all that data. So imagine your app blows up overnight and you've got 1 million users. Especially when you consider your design choices, your data could quickly scale to be from hundreds of megabytes to gigabytes to terabytes of data. And now you're stuck with your user's experience depending on these servers that you have to keep up and running or pay for, where they can keep their data to keep the app functioning properly. So I'm going to encourage you, when you're early in your learning, to focus a lot on client-side applications and fully utilize the power of client-side applications before you start to do too much with server, because you can learn a lot of things. Like, for example, you think, oh, well, I want to learn databases. I want to learn, the fetch API or something like that. But you can actually learn a lot of that stuff by managing those things using cutting-edge client-side features, things that you can do in the browser to save data on the user's device, but still learn a lot of those things about, like, let's say SQL, signpost SQL, SQL, structured query language. You can do that on the client side and manage a local database on the user's device. So we have this first type. You just have an HTML file, you give it to somebody who's willing to serve that asset, they serve it out to the web, and you're done. Then you have type 2, where you have static assets, and inside your static assets that somebody agreed to serve for you, you have JavaScript that calls out to external APIs. So those APIs are going to have to be running 24/7. If the user wakes up at 2 a.m. and they want to call GitHub to get your static asset, they should be able to do that, and they should be able to, the JavaScript inside of that static asset should be able to call whatever server contains their data at 2 a.m. and it should be ready to go at 2 a.m. ready, listening 24/7, 99% of the time, high reliability, and they should be able to get that. So that's type 2. And then type 3 is, well, what if the server is yours, right? What if you maintain all those servers? You could serve the static assets and you could serve the dynamic assets together. And you're like, yeah, okay, that sounds like basically you're just GitHub at that point, right? But not really, because you can do sort of more clever things when you have that structure. So for example, let's say I have a database on my computer, and that database is going to contain all of the data for the users. They're going to be able to log in, and then they're going to be able to put some simple data there, like the classic to-do list app, to-do items. And so each user has their to-do items, and they should only be able to see theirs and not other people's, blah, 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 blah. So what happens? I decide to speed up my app. What I'm going to do is I'm going to have a single dynamic application that I run. So I could do that. I could write that in Node. I could write Node.js, that is JavaScript. It's a JavaScript runtime for lots of different operating systems. I could write it in Go, or I could write it in C or C++, or Rust or Python. And I'm just going to say, I'm going to create a web server. Web servers can serve static assets, or they can serve dynamic content, meaning rather than serving files and folders, they can just serve whatever they want. So if I'll just set up, endpoints, they're called, signpost endpoints, HTTP endpoints, so that when somebody calls or contacts my server, I'm going to respond in this certain way. So if they ask for, my web server, whatever that is, say it's reg. Or let's just say it's n.gardella.cc. Let's say I run that server myself, or I say, let's call it local.gardella.cc. So I run local.gardella.cc, and that's out of my house. And it's a computer in my house, and when you call that domain, the DNS service will literally call my house, or call maybe a third party that I use for security, like Cloudflare, calls Cloudflare, and then Cloudflare calls me, and then I handle that request, and my server is going to have to run 24/7. Okay, this isn't static assets that I can just make one time and give to GitHub, or give to HostGator, or give to hosting.com or whatever. I'm going to have to run this server 24/7, right? If my power goes out, my server goes down. You can see already how this is a challenge. Or I could run this in a cloud, and I could pay some cloud provider like Amazon Web Services, Signpost Amazon Web Services, or Oracle, or Google Cloud Platform, to run this service in the cloud. That way take advantage of their scalability and their ability to run their servers 24/7 with very little downtime, which is called reliability. Signpost reliability. Amazon Web Services will promise very high levels of reliability. For example, they might say, we promise 4 nines of reliability. What that means is 99.999, however many 4 is, 9999 % of the time, our servers will be ready to handle your requests. So they're saying, no matter what, we're going to have, even if there's a hurricane where the servers are, and the whole thing goes down, the whole building goes down, and the power's out, there will be some backup to serve this stuff. But, let's go back to the example. I'm serving this out of my house. So let's say I have an application that I wrote in Python, and it just says, whenever you call my server, local.gardella.cc, using HTTP, the Hypertext Transfer Protocol, and you say /to-dos, you're going to provide some authentication details inside of that request so that I know which user you are, blah, blah, blah. And I'm going to respond with the to-dos for that user in, let's say, JSON format, JavaScript object notation, signpost JSON. I'm going to respond to that web request with that piece of JSON. Or maybe instead of that, I would respond with an actual dynamic web page. I know this is confusing, but I could put whatever I want there. You see, I put text there, I could put JSON, I could put an image. But when you call to-dos through your browser, actually what I want to do is do something that your browser can display, which is HTML. So I'm literally on my computer. I haven't sent the request out yet, right? This is a piece of mail. It came in. You asked for local.gardella.cc/to-dos. And you put in there your credentials, so I know which person you are. So I'm going to go, I open this letter, I look at this, and I say, okay, let me check my database to see that you're the user you say you are. Okay, I found you. All right, let me check my database and see what to-dos you have in my database. Okay, I found some to-dos, and now I'm going to send those back to you, but I'm going to be clever about it. Instead of sending you an HTML file that has no to-dos and using a request to get that data, that was type 2. That was, we had static assets we gave to GitHub. GitHub put out our website, and then some JavaScript went and called a service. For example, if I had the GitHub had my static assets, my front end. GitHub was serving my front end. You get the HTML file. It has a template for the to-dos, but it has no actual to-do data in there. And it has some JavaScript that will call my server. And in this scenario, my server responds with JSON. So it sends the to-dos, it sends basically a list of to-do data that isn't very pretty for the browser to look at. But my JavaScript inside my client-side code that I gave to GitHub is going to call my server whenever the user has this page. I'm going to call my server, get the to-dos, inject them into the page so that the user can see them, and then the user sees the to-dos. So in this, now we're going to switch over back to type 3, the one where I'm running the web server. Forget a GitHub. I run the web server, and I'm going to serve a dynamic website. So I'm literally going to, before I ever send the letter back, before I send the request back for my website, I'm not going to send them an empty template where to-dos could go later. I'm going to literally inject those to-dos on the server side. So I'm going to place the to-dos in HTML, ready to go, ready to look at. So as soon as that request resolves to the user, as soon as I send that letter back and it gets back to them, that data is there. So they don't have to call two places. They don't have to get the HTML file and then call another server to get the data. They're getting the HTML, the client-side code, the client-side document structure, and they're getting the data into one request. So that can increase performance, but like I mentioned, that means that the power can't go out. And I've literally run things out of my house before. The power goes out, guess what? My server's down. And sometimes it doesn't have very good fault recovery, so I have to restart the computer manually, or I have to go in, and it tried to connect to the internet and the internet wasn't back up yet, so it's offline. I have to restart the computer to get it back online. So these are real problems that you'll encounter if you try to run your own server, which is why people turn to the cloud, but then the cloud gets expensive. So all this rant to say, think about those 3 types of websites. If you feel like you're drinking through the fire hose right now, you're not alone. A lot of people feel this way, but this is a really fundamental thing I want you to understand, is that you can have completely client-side websites, right? You produce your app, you can use Node and bundle up an app and create this crazy thing, but ultimately it's just going to come down to static assets that you give to a hosting provider like GitHub or HostGator. Then you can have the second type is you have those static assets that you build however you do, and then you give them to your hosting provider, and then in turn the hosting provider gives those files to the user. But when it gets to the user, some of your JavaScript that you wrote inside of that code, in that code or those assets, will then call external services that have to be up 24/7 in addition to the web server. And then type 3, where you can speed things up by integrating that all into one place. So you run the web server, you put the web server in the cloud, and it responds to requests dynamically by injecting data into the assets before they get sent out, and basically customizing assets for you. So whereas when you ask for the type 1, when you ask for this type 1 website, 100 different people asking for the website, they'll get the same thing. Type 2, same thing. 100 different people will get the same code, but then the JavaScript, based on the credentials they enter, the JavaScript will get different data for them. Type 3 is all users will get a different experience because the HTML is customized as it gets sent out to them in real time using a single server. So those are 3 big things I want you to understand. And then the next one, I mentioned we started talking about this most basic type of JavaScript, the JavaScript that runs in the browser. There's also a JavaScript that you can create using you can tie in dependencies. And so for example, let's say you have a library like the Lodash library. You can pull in that library using a script tag, and you can either serve that asset, that JavaScript file from Lodash. You can download that from Lodash and serve it yourself, or serve it alongside the static assets that say you're going to give to GitHub. Or you could get that from a CDN, a content delivery network. Now you've added a place where this is kind of like that type 2, where when that file gets to your users, it originally got sent from GitHub, but now that to get that JavaScript file for, say, the Lodash library from a CDN, a content delivery network, there's going to be another HTTP request made to get that from a different static web server somewhere else. So that introduces the challenge that maybe that CDN could be down, and if that CDN is down, now your dependency is not going to come in. But CDNs are meant to be kind of reliable, and actually they're meant to speed up your site and reduce the load off of wherever you serve your assets out of. So they can be advantageous, but just keep in mind that when you add a CDN script to your HTML file, then you're depending on that CDN to be up as well as the web server that's serving your assets. So then the third type is bundling. So why do we do bundling, and what is bundling? Bundling is basically taking a bunch of JavaScript code, your code, all the libraries that you want to bring in, and packaging it up into a stripped down version that just has all of the pieces that you need. Because let's say you have 100 different dependencies, 100 libraries in JavaScript that do clever things that you want to include in your app, but you only use one function from all of those libraries. If you include all those libraries from, say, CDNs, or you download the JavaScript files for them, and you put those static assets with your app in GitHub, then the size of your app, the size of the things that users are going to be requesting when they go to your web address, maybe 100 files are going to get pulled down behind the scenes when they go to a single web address. And that could be, maybe that's 400 megabytes of JavaScript files, for example. That's going to be a big storage requirement on the user. It's going to take a long time for those requests to complete. And it's just overall going to create a buggy, laggy experience for users. And it's just unnecessary. You're just shipping more code than you need to. So what bundlers do is they cleverly figure out which aspects of the app are necessary, and it keeps those, and it gets rid of the rest. So it takes all of your JavaScript and it tries to get the smallest possible piece of JavaScript. It ends up looking like gibberish at the end, but you don't care because it just works when you get everything right, and it allows your app to, you write your code in a way that's very readable and understandable, and then you bundle it, or you build it where a tool or another program, a tool chain or something, will build your app into a consolidated set of assets, a smaller set of assets that does everything that you want but strips out all of the unnecessary BS. And then what you do is you take those built assets, and then those are what you give to GitHub, for example. So the advantage is you could take 100 library imports and you use one function from each, and then you build it, and the JavaScript bundle, meaning the code, the assets that are left over after the build process, are much smaller than if you had included the full source code, the full JavaScript for all of those libraries. And so it is to your advantage to use a bundler. Even if you're using vanilla JavaScript, a bundler can be to your advantage if you have a lot of dependencies. Another advantage to bundlers is that they can help you to target, meaning that the end result of your code after a build step is going to be something different from what you wrote. So what do I mean by that? Remember how I mentioned that the JavaScript standard evolves over time? So let's say there are, there's an older browser that you want to support, and your code is compatible with newer browsers but not older browsers. So a bundler might help you to target, meaning have the end JavaScript result be translated into a version of JavaScript that can run in those older browsers, for example. The other piece is that bundlers are very commonly used with frameworks like React.js or Vue or Svelte or any of these. It's probably possible to use those without bundlers, but it's very uncommon to do so. And so it's just going to be better if you can use a set of tools to set up your project for you and have all the bundling prepared, and then it's going to allow you to create those static asset bundles from your code. So you can write your code and you can import code. And the other advantage to using this type of technique is that you can use Node.js to get your libraries imported from NPM. So NPM is the Node package manager, and it comes with the Node.js JavaScript runtime. So at high level, Node is just one way, there are many ways, to run JavaScript on your computer without a browser. But what it's practically used for is people use it to create projects that have dependencies, and then they use NPM, the Node package manager, to add those dependencies to their project. And then what happens is when you use a bundler, like for example, a popular bundler is Webpack, another popular bundler is Rollup. If you use a tool chain to set up your project, like for example Vite, V-I-T-E, signpost Vite, signpost Webpack, signpost Rollup. When you use Vite to set up your project, it will set up the Rollup bundler to be used through Node and using dependencies from NPM, so that you can simply do NPM install Lodash, for example, the Lodash library, and then you don't have to download that JavaScript source file yourself. You don't have to use a CDN. You just import in your code. You just use an import statement from Lodash, and then you can start using functions from Lodash. And then you're like, well, why can't I just do that in regular JavaScript? It's just not how the browser is set up to work. So what the bundler does is creates this bundle that the browser is going to understand. And so it's going to work in a way that the user just goes and everything just happens using the browser's native capabilities. But in your code, it can be much more convenient to just install dependencies from NPM, the Node package manager, and those will live in Node modules inside of your local project. But Node modules gets really big because it has all the JavaScript for all those different dependencies, and then when you run your bundler, it just picks out the important parts of those Node modules that you actually used, and then the code that you wrote, and puts it in this nice little package into a folder called like build, or called dist, D-I-S-T, or called maybe docs, documents. Like if you want to have a documentation for a GitHub repository, they often put those in a docs folder, and then that's what your GitHub Pages site would be in your repository. You have some code, and the documentation for it is a GitHub Pages site on the same repository. But commonly it's called dist, D-I-S-T, for distribution. It's a folder that will be created inside of your source folder, or inside of your root of your JavaScript project that you're working on in Node. Now you're just working on it in Node, but because you're building to a bundle using a bundler, you actually don't need Node to run the application. You just need a browser. So another confusing thing here is that Node can be used to create dynamic servers. Like for example, that one I talked about, to-dos. I run the to-do server where I create a customized HTML page for you when you ask for to-dos. I send you the customized HTML file that I created before I even sent the request back to you, checking the database and getting your to-dos and injecting them into the HTML and sending it back. I could do that with a Node application. So I could run Node, and my computer would literally have to be running a process, meaning like an instance of a program would literally have to be running the Node program, and then executing the JavaScript for my app in real time in order for that application to work. I could also write that in Go or Rust and not use Node. But that's one way to use Node. And then another way to use Node is just in development. So for example, we're creating a fully front-end static website, but we're going to use a bundler so that we can have all those advantages I talked about. And we're going to use Node just to develop the app, right? Just to include dependencies and test the app while we're developing it. And then we're going to use a build command that uses Node to build the application. But now we're done with Node. Now we just have static assets, and we can send those to GitHub or whatever hosting provider we want, and they can serve our website, and we're done with Node. We don't have to keep a Node process running on our computer 24/7. And so that's a big advantage to creating static websites, and why I'm going to, again, encourage you to see how far you can go with a fully static website, because the limits are way further out than you think, and the consequences of having a dynamic server, while there are benefits like speed, for example, there are definitely a lot of drawbacks. So I think that should wrap it up for this rant. You probably heard a lot of new terms today. You may be left more confused than when you started, but hopefully this was helpful, and some of those explanations have filled in some of the gaps. Thank you for listening, and I will talk to you in the next one. Bye.